Hi everyone, welcome to Docker Workshop. Sorry for delay. Due to some technical issue, we got a little glitch. So our agenda is a little packed today. We'll go through the Docker basics. We'll go through basic Docker and container details, and then we'll show you the Docker labs, and we'll follow the Docker labs. Remember to go to our website, sharelearn.net, and sign up on docker.com account. So you have to go to get started and click on sign up, as we'll be using labs from there. This will be the screen. It'll only ask you to choose a Docker ID, have an email and a password, and selection captcha. And once we are done with the Docker basic, we'll be going over the Docker labs over here. So practice Docker labs. Let's start with the basics. So, what is a container and what is a Docker is a very common question and a really new thing in the application development and system administration. So, let's see how things were done in the past. Earlier, we anytime you want to deploy an application, you need to buy a server, which is bare metal. So, you have to order a new server, install it, attach it to the network, and then install an operating system on it. Then you'll have your application on it. Every application has its own servers. Even the application has multiple servers for redundancy and different roles in them. Then we had virtualization, and that what we were doing is we were getting the servers, connecting them to the network, and getting them up and running, installing a hypervisor on it, which acts as an operating system but let you create different operating systems and virtual machines on the top of it. Now, this was still an overkill because we were wasting a lot of resources as we were deploying operating system again and again. So the containers, how they solve this problem is you get the servers, install a host operating system, could be CentOS, Windows, or any Linux flavor you want, and you install Docker on it, and you abstract every process as its individual container. Now, container has been for a very long time, but Docker makes it very simple. Earlier, it was very complicated to set up a cluster and set up a container and get it up and running, but Docker makes it very simple. That's why it becomes Docker container, although Docker has not much to do with the container technology itself. Docker is the tool to manage the containers. Now, why containers? Containers are flexible, they're much smaller, and they're portable. You can move them very easily. Just in the earlier example, you have seen that earlier we used to have a separate server for every application. Then we had separate virtual machines for every application. And a lot of resources were going wasted. And in the virtual machine, it was still hard to move a virtual machine from one server or one location to another. They are loosely containers are loosely coupled. They are scalable. So if you want, you start with a smaller scale of let's say 5 containers, and you want 50. It's very simple to bring a larger scale to them. They're secure as you'll be opening only limited ports outside. The virtual machine used to be wide open, then we lock it down, and then open only certain ports, which was not very helpful and not a simple process to do. In containers, we only open the port which is required. So, how do this solve the developer from the developer mindset? What were the problems, and what is the things that containers solve? Well, there used to be a test environment and a development environment. Developers will either work on a local desktop to develop an application and then give it to the tester after building it. And the testers has their own environment, either servers or local. which they were doing these testings. And there could be a very small change or a very simple change, you could say, that they were using different version of a particular programming language or a library. That is simple to say. Or there could be some complicated changes in their environment, and that will break the code. So there has been many times when a developer will say everything works on my local machine, and tester will say it's broken on mine. I cannot take your machine and deliver it to the production or to the client. Docker solves that because you're packaging everything around that application in a container, and you give that same container image to the testers to use it. So there's no ambiguity between the developers and the tester and the environment they're looking at. The way it works is generally you'll build a Docker. You'll take a file, name it Docker file, put the information in there. We'll be looking at more details about those in the lab. You'll build a Docker image from the Docker file, and then you'll run the container with that image. In the backend, generally you'll have a client running on your server where you'll build, pull, or run the image. And then you'll have a host where you're actually running the containers, and you'll use a Docker registry, default is Docker Hub, to pull the images. So you'll build an image, you'll push it to the Docker registry, and when you're required to run it, you will pull it back and then run a container. So a client is where you initiate all these commands, Docker host is where actual containers run, and Docker registry is where your containers images are kept. Again, a container provide namespace isolation, so it has its own process IDs. It manages its own network interfaces, its own IPC resources, and file system, and even on the kernel and version identifiers. Okay, so that was the basics. We will open it up for the question and answers. Feel free to put the comments down, and if you're joining via YouTube Live. And we also have a Google Meet link in the YouTube Live comments. So if you want to do the workshop with us, the labs with us, feel free to join in. And if you happen to do these later, leave us a comment and we'll be happy to help you in any of the labs you might have any, or around containers and Dockers if you have any issues. So make sure you mute the YouTube Live if you're joining the Google Meet. Okay, so to start with, you have to have a Docker Hub account, sign up here, and then go to our website on sharelearn.com. And in the practice section, there is Docker Labs, which is the top one right now. Click on let's go to first lab, which is Docker Lab 101. It's just a hello world, but gives us a good insight. So click on Start Lab. It'll take you to the sign in with Google. It's a mix of sign in and sign up. It just takes your ID from the Google side of it. So let me just get it here. Yeah, once you go to the next page, it just asks you to select your Google account and click on that. It'll bring you back, and then it'll take you to your profile page. Um, Profile page right now is accessible only when you sign in or sign up at the initial time. Um, just go around and look into edit profile. Feel free to add in your LinkedIn, GitHub, and Stack Overflow information or some bio if you want to add. There's also an option to subscribe to our newsletter. It's checked by default, but feel free if you don't want to have that. Feel free to unselect it and save it. And I'll cancel it here. Go back to the practice and Docker labs. Start the lab again. This time it'll take you to the actual lab, and we'll go through the lab now. So the first step, it'll ask you to create a Docker Hub account, which we already discussed. Click here, and it'll take you to the Docker Hub site. Make sure you sign up over there. And then the next thing we want to do is go to the play with Docker. So this is the lab environment we'll be leveraging. And here you go to Docker login and go to Docker. There, it's going to ask you the ID. So if you see the screen here, it says user ID and password. Enter those, the one you just created or you already have Docker Hub account. Click on sign in. And once you have this, click on start. So all these details are available here. Once you're here, click on add new instance, which is over here. That'll spin up a new instance for you. So we will be running Docker container hello world. So if you want, you can copy from here and just go back, click on the terminal and hit enter. What this will do is it'll pull the image from the Docker Hub, download it, and then run it. And this image, all it is doing is printing this message, hello from Docker. This message shows your installation appears to be working correctly. To generate this message, Docker took following steps. Docker client contacted a Docker daemon. So Docker client is generally run on the local machine, and Docker daemon is run on the servers where we are hosting our containers. In this case, it's a very small container just showing this message, and that's all. So Docker daemon pulled the image and created a new container for that image, which runs executable that produces the output you're currently reading. Docker daemon streamed the output to the Docker client, which sent it to your terminal. So coming back to our lab, now the container has stopped because that's the only task it is supposed to run. So if you want to check if there is a container, so if you do Docker container ls minus la, you'll see that there was a container which was created about a minute ago and it has exited about a minute ago. So this container was spin up and it has exited. So it's in the exit stage right now. Now you can check the Docker images, which are already there. We will be building the images and working on images in the next labs. But if you want to see the image, run the command Docker images, and it'll show you the image hello world and a tag, which was latest in this case, which was used. If I go to the next one, it asks me to inspect the container. So in this case, I will just take the container ID and say Docker inspect, and then I put the container ID. Now it spit out a lot of details about the container. We will be going through these in further labs, so you don't have to worry too much about it, but it's just the information about the container which we just ran. You can also inspect the details about the image. So take the image ID and this time put the image ID there. And here it is giving you information regarding the image detail. Again, we'll be working on the images in more details in the next labs. So the next one is if you want to run your container again, you use the Docker container run. And these are the options available for you to use with it. Now, the next is to clean up, and we will continue during this workshop with the same setup, but if you're done, you just click on delete and that'll delete this instance and then close your session. So with that, the first lab is done. Congratulations. And we also have a YouTube video on this lab. If you happen to get stuck at any state or looking for more detail, watch that video and that'll help you. So click on done here. Let's start the next lab. In this lab, we'll be interacting with the Docker container. So again, if you don't have it already, create a Docker Hub account, log into the Play with Docker, create an instance, which we already have in this case. So here, what we are doing is we are pulling Docker images. And these are the list of Docker images we are pulling. And if you want the answers, just click on solution and that'll give you the answer. For now, if you go back here and do Docker pull Ubuntu, so you'll see that you actually pull that image. And the task is to pull all the images which are listed here. So let's do that. What we are doing is we're getting different version of Ubuntu. So we got the latest version. We got the 1804 2010. And in the next one, we're getting 1604. Now, Alpine is the smallest version of Linux which you can use in the Docker container, and it's very popular. A lot of things are done in that. So we'll pull the Alpine image as well with different tags to get familiar with the commands which you could run in this. Okay, so this step is done. Here we're checking the Docker images. We already know the command, but if you happen to look for a solution, you can click on that. So Docker images, and you'll see all the images will be listed here. As we're continuing from previous lab, it is also listing hello world. But if you delete the instance and create again, it will only show the images you have pulled. So we have Ubuntu latest 1804, 1604, 2010, and then Alpine images with different tags and different versions. So here so in the previous one, we just checked the images, but the command also have a -a tag. Sometimes images are hidden. Some of the images will not be visible in the previous one. So use a -a to look at all the images. So now there could be a time when you have a huge list of Docker images on the host where you're running it, and you would like to see all the tags for a particular. So in our case, we have Hello World, Ubuntu, and Alpine, but there could be a bigger list as you work on these things. So if you want to check all the tags which we have from Ubuntu, all you have to do is run docker image Ubuntu, and it'll list all the different versions or tag you have for that image. Now we're doing it same thing for the Alpine. Sorry. So there's another set of command which is docker image ls, which gives you the similar result, and ls minus ls minus a, which will give you the all version of it. So docker image ls will work as docker images, and docker image ls minus a will gonna list all the images. So let's run a command inside our Docker container. And if you have to do that, all you have to do is say Docker container run and the image name and the command you want to run. So in this case, what I'm doing is I'm taking the Alpine image, creating a new container, and running the command ls minus l inside it. So all these files which are listed, they're coming from inside the container. Now this time I want to run an echo command. It's a multiple. In the previous one, we just run one command with an option, but here you can run echo with the inverted commas and an option here as well. So you just get a echo reply from the Alpine container. Let's run. Now let's say you have to get inside the container and run some command inside the shell. You could very well assume that this should work. It should, you just put in bin and sh and it should take you to the shell prompt, but it doesn't because the container get created, a shell command runs, but there's nothing to hold you and give you a prompt. For that, what you have to do is use the it. So you have to do docker container run and option of minus it. I is for interactive and T is for terminal. And as this is an Alpine image, it uses ASH shell. So if we do that, it'll take you inside the container, and now you have a container shell. Let's create a new file and enter a command, enter a message hello world inside it. So now if I do cat hello.txt, it'll show me the content of the file. Let's list all the containers. So our command was docker container ls. Oh, we're inside the container. So here we will run. So in order to get out of the container, you have to type in exit command. And here we will type in docker container ls to list all the containers we have. And you'll see it shows nothing because that's only the running containers. And if you do minus A, that'll show you all the containers we have spin up so far. So we started with hello world, then we did the Alpine with ls minus L, and then we did the echo command. We tried to get into the shell without the IT options, and that doesn't give us the result which we were expecting. And then we spin up a new container with the Alpine shell. Now, the next thing we have is we want to start one of the container back, and let's do the last one which we created. Now, you don't have to copy the entire container ID. All you need is something which can remove the ambiguity. So in our case, even if we type in C, that'll take the right container. But just to be consistent as a practice, take this Docker container start and this container ID from here. Let's do that. And that started our container. So now if we do ls, we'll see that this container is up and it's up for 4 seconds as we just ran the command. So next is to connect to the container. You can also do, so when you already have a container running, Docker container run will not going to help because that will going to create a new container for you. So if there's already a container running and you want to get inside the shell or interact with it, you have to use the command which is exec. So exec. And in this case, you have to give the container name and of course the ASH for the shell. So we are inside this shell. Now if we do ls minus L here, you'll see that our hello text is still there. So you're not going to lose the content of what you do inside the container if you just stop it and start it. So the next step here is the cleanup, but we can interact more here and see that our file existed and nothing happened to our file. So if you want to come out, do that. And as you finish after the cleanup, we have a video for this lab as well. Let's go to the next one. Again, the same steps as if you're starting as all of those you have to do the spin up the environment and create the instance. So these steps will be common in all the Docker labs. So let's go to the so in this case, the task is to run a Docker container with image Ubuntu and connect to perform below command inside the container. So we want to do apt-get update, apt-get install figlet, and then run a command figlet with a hello as its options. If you expand the solution, you'll see that what we're doing is we're doing Docker container run with the interactive and shell, Ubuntu, and Bash. So let's do that. We are here. And now we have to run these commands, which we got as our instructions. So apt-get update, we're going to update all the repositories. And let's install Figlet on it. And we print the message hello Docker from that. As we're done, we're going to type in exit. And if you try to list the containers with the Docker container ls, you'll see that that's not the container you have it up and running. This is the Alpine container, which is still running. So let's do Docker stop and stop that container, which is running from the past, from the previous lab. Okay, coming back to the lab, we have run these commands after going inside the container. List all the Docker containers. Yeah, let's do that. So ls will not going to give us because that's only the running containers. We are looking for the container, all the containers. As whenever you do, whenever you bring a container with the run command and you don't do -d for the daemon, you will gonna have those challenges that you would have to. It'll stop once you stop interacting with it, so you would have to start it back again. So here, you have to check the changes you have done to the Docker container. So this is our container, and let's say we want to check what changes have been done to this container from the image which we got. As image is one state of the environment, and then when we make the changes, they get recorded as well. So it works as a version control. Oh, my bad. Docker container diff. So it shows you the list of commands which have been run after the image. So there's one set for the images. We're going to go into those details as well. But then it tells you that these files have been added in the repo. And then it'll show you that Figlet has been entered and installed as well. So let's create a new image with the changes we have made. So now if I list the containers, I'll do, and let's say I want to make, I got a Ubuntu image. I made my changes in it, and this could be any image or any code which you have been working on. You made your changes, and now you want to make a new image and give it to anybody else to be able to run. Let's say you did some coding and you built a container image out of it, gave it to the tester. Tester give you the bugs out of it. Now it is back to you to make the changes inside it. You get into the interactive shell, you made the changes there, and then you want to commit it. Again, there are multiple ways to handle it, and in the next labs, we will be doing it in a different way. But one simple way will be to just make the changes inside and then commit it with the container ID. So I took the container ID and the command docker container commit. Okay. So now if I'll go back to the lab, it is asking me to list all the images. Let's do that. You'll see that one of the image, which was created 12 seconds ago, has no name on it and no tag on it. This is the image which we have just created by doing a commit. So we got an image from Docker Hub or internal repository if you have one. We got inside it with the interactive shell, make the changes. In our case, we just did the apt-get update and then installed Figlet in it, but you could do major changes, whichever one you want. And then once you exit out, you can use that image or the container, that container to create the um, new image, which could be sent back. Okay, so now we want to change the name on that image. And that is done with the tag command. So it's Docker image tag. I take the image ID from here. And then I just want to name it what is in the task. So I'll name it first image. And task also asked me to tag it as 1.0. So I'll tag it 1.0. So I have Docker image tag, the image ID, which comes from the Docker image ls minus a, the name which was given in the task, and I put tag ID after colon. Okay, now if I do ls minus la, you'll see that we have the name for the image, we have the tag, and it states that it was created a minute ago. Let's go to the next one. List all the Docker images. We already did that. Okay, now the task is to run the container with the image which we just created. Now, in this solution, we're using no tag, but you can use the tags as well. So we're saying Docker container run first image, that's the name of the image which we just created. And we're asking it to run the command figlet and hello. And the complaint came back that there's no first image with the tag latest. That's the default tag. So as we have given a tag of 1.0, let's give that and run it again. And this time you see that the figlet came in, and that's because we have taken the Ubuntu image, installed the figlet, and we're just running the command inside it. And that was the thing which we planned to do in this lab. So we can go to the next lab. Again, the cleanup process is simple, which we discussed earlier. So let's go to the next lab, which is 104. Here, we will be creating Docker image with the Docker file. So initial steps are same. We already have a session with the play with Docker, and we already logged in. We already have a instance created. So here it's asking us to work on Docker file. So what we are using is VI, which is the editor in Unix and Linux, to edit the files. And you do VI and then you press I to go to the insert mode. In the solution, we have provided the Docker image and explained what we're doing, but I'll do it here as well. So if you look at it, we're in the Docker file, we're stating that we will going to start with the Ubuntu image. We're going to run apt-get update. And then another command we're going to run is apt-get install figlet. We're going to run a command. Command is only run once, and that acts as an entry point for the container. So as long as that command is running, the container will be running. In this case, we're giving figlet as the command and hello Docker as the option. Now, in order to get out from the VI, you have to press the escape key and then colon WQ. Okay. That creates our Docker file. So if you do ls-la, you'll see a Docker file has been created. So now the next thing is to create the image. And the command is docker image build -t for the tag for the image. And we're saying image from file, which is just a name we're giving it. And then we're saying tag is 0.1, and we're telling the location of the Docker file, which is used with the dot notation. Please don't forget that. Otherwise, you have to provide the location of the Docker file. So if I hit enter, what the Docker is doing is everything we stated inside the file. So it's getting the Ubuntu image, it's doing apt-get update, and then it's installing the figlet for us and running the command. And for every step we have mentioned, it creates a local image which it can use and reuse for making changes. So next time if I make the changes, it's not going to fetch the Ubuntu image again. It'll not going to create a new instance. It'll just use this part of the image. Now if I do Docker image ls-a, you will see that few images have been created. These are the step images which will be cleaned out. So this is the image which we have created, and this is the tag we have created. Now, next step is to run a container with the image we have created. Now, we have not gone through the process of pushing the image to our registry. We might add it into this lab in future, but you can always use a Docker push command. Just understand the moment you try to push it, it'll gonna ask you your credentials. And this is a shared environment. This is a lab provided with lab play with Docker. So it's still a shared environment, and it's not recommended to push your credentials and other things inside it. Anything which is related to your can be identified to you back should not be used over there. So let's run a container with it. And as you see that our container did not have anything to run it continuously. That's why it just ran that message and you're done. Let's go to the next step. Again, list all the images, which we have already checked that we have image from file and we have few extra images, which are from the steps which we have run. So let's check the history on the Docker image. If we do that, now you have to provide 0.1 unless your tag is latest. If you use the tag as latest, that is default and you don't have to use it. So you'll see that these are familiar changes. We made those changes. apt-get update, install figlet, and then command. But there are a few changes which came um, 2 weeks ago, and those are the changes which were on the Ubuntu image which we used. So these are before, when you run the history, it'll show you from where the image was created, when was the last change made on it, and it'll give you details on that aspect as well. So next is to modify the Docker file. So in this case, we're going to use again the Docker file. So let's let's say it's a big code and you're making changes inside it. It's not just a figlet running hello Docker, but you have a lot of changes made in your setup, and you want to make these changes here. So again, you'll go insert 0.2, that is the ask for us, and rest all things remain the same. Do an escape and do colon wk. So now we have to build the image with the updated Docker file. And the way we do that is using the same build command which we used earlier, and we just change the tag over here. So we'll do it with the .2, and you'll see that this time it was much faster because we already has those steps built earlier. Docker just reused those images and made the only changes which we have made here. Let's run a container with our new image. So again, the same command, docker container run image from file 0.2. This time, the message has changed, and that's just to state that whatever changes you have made will be saved and the image will have those incorporated. So this is a complicated change in your application, you will make changes in the Docker file, you'll build an image, and you can push it to your internal Docker registry or to the Docker hub so that somebody else can pull from there and use it with the changes you have made. Again, that ends this lab. And we also have a video for this lab as well. So feel free to go through the video. That was the planned labs, which I plan to do in this workshop. So let's go through the questions you might have in the comments and anything you might want to ask. Also, if you go to our website, we have these uh, Docker labs. We also have Kubernetes labs. We are working on Linux and Cloud labs, which we'll be adding soon. So feel free to explore. Tomorrow we have a Kubernetes workshop. So we'll be going through similar setup. We'll go through the basics of Kubernetes and we'll go through these labs. But there's already video inside the lab. If you have any, feel free, you can start the lab. But if you want to go do it with us, we will have similar setup tomorrow where we will have a YouTube live with the Google Meet setup. So if you're stuck in any lab and you want to share your screen, you can join the Google Meet, and then it'll be a different invite for tomorrow. Uh, so you can join there. Yeah, let me see if there are any comments or any questions. We are also coming up with the certified Kubernetes admin FAQ and details. So if you go to our certification section and Linux Foundation, we already have a study guide on CKA and CKAD. We'll have sessions on those as well. So feel free to join. Keep an eye on Eventbrite and on the Facebook group and the Telegram channels we have. So you'll get information about those. Okay, yeah. So a good question came up. You can access these labs anytime. They're provided by Play with Docker. There are limited resources, so there could be a situation that this lab doesn't spin up an instance and maybe ask you to try later, which happens very rare, but there could be a situation when that happens. So just bear with it. It's a free resource, so not much could be expected in terms of availability from there. Yeah, another question is where can I find the labs? If you go to our website, go to practice Docker Labs. All the labs are available here. We'll be adding more soon, and all of them will be available here. Um, you the moment you click on Start Lab, it'll take you to the screen for sign in. Um, Sign in and sign up is the same on our website. So when you are signing in with Google, it'll just take your credentials and create your profile. And for the future, your profile stays there. But the process stays the same. Anytime you sign in, you go to the Google, authorize yourself, and then come back here. Yeah, we also have engineering blogs and books. You can find very good books here in the book section. And we have courses and events as well. So these will be moved to the provider section soon. And then we're going to have courses listed here. In the events, you'll find the future workshops here. We also have free Microsoft Virtual Days, which gives you Azure side of things. These are provided by Microsoft, so feel free to browse through our website and check what might interest you. Another question is how do we file a bug or how do we send a feedback for the lab? So if you go through the lab, there is an option to report a mistake. It's a bug reporting tool and it'll take you to GitHub where you can open a new issue. You would have to sign up with the GitHub and give the details of what you have experienced in which lab. Ideally, give us the URL and URL changes on different steps. So give us the URL and tell us what you feel we should improve on, and we'll be happy to make those changes. There's also a shortcut on the homepage that you can find the Docker Labs here, so you can directly go there, or you can go via browsing. So leave a comment. Definitely like and subscribe to our channel. We have a lot of information. A lot of things are in progress. We'll be adding more labs, more guides, and more topics on it. Um, Feel free to give us the feedback, whatever you feel like. We don't feel there's a negative feedback. We always take it very positively. Whatever you have in mind, share it with us. And in a rare case, if you feel like we did a really bad job, feel free to drop a dislike there as well. We would definitely love your feedback and have more information. Um, Definitely will going to help us to improve it. But your likes really help us to get the motivation to work on these things. So if you have any specific questions where you want to share your screen, feel free to join the Google Meet or in the YouTube live as well. You can put the things in the chat or in the comments. Either ways, feel free. We'll be happy to work on it and get back to you as soon as possible. With that, I guess we're closing on time. So thank you for your time, guys. Tomorrow we have a Kubernetes workshop. So feel free to join. Sign up process is the same. Go through our Eventbrite page and get the information there. Look at the labs, share your feedback, help us improve it. Definitely, we need your help to improve these labs. And we'll be adding more and more complicated and more um, practical scenarios as you get familiar with the environment. Thank you. Thank you for your time, guys. Have a great day.